Hello everyone. Let's go through the medium LeetCode problem of adding two numbers and solving it in Java. While going through it, I will try my best to explain the thought process so this may help you in your future tasks. Now let's read the description. You are given two non-empty linked lists representing the two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. So we have an example, which is two linked lists, 2, 4, 3, 5, 6, 4, and we get this result. It's also explained that it's actually reversed. So the actual number is 3, 4, 2 and 4, 6, 5. So we add these numbers and get 807, but the output is going to be reversed. So we have two numbers and we need to get the sum of them. Sounds simple enough. The difference from the simple addition of two numbers is how they are represented. And they are represented as lists of digits. We will discuss how that could be important later. I would also like to point out the structure that is given to us, the list node. This is an unusual representation of the number given how description talks about linked lists that are actually present in Java. But we will have to work with what is given. If you didn't fully grasp the structure from the get-go, just like I did, then I will give you an example of how it looks. As you can see, I took the structure and put it into my code, but I also added to string. I also took two numbers from the description, and I will show how this list node actually looks like. So we have example 1. Number 342 is inverted, and now it's linked list of 243. As a list node, it looks like this. Value 2 inside list node with value 4, and then list node with value 3, and nothing inside of it, because that's where it ends. The same goes for the next number. I think it's important to understand this structure before starting your task. When I read this problem, I was immediately tempted to do it in the most basic, straightforward way. It consists of the following steps. Step 1. Create multi-digit number 1 from the list 1 instead of working with the list 1. Step 2. Create multi-digit number 2 from the list 2 instead of working with list 2. Step 3. Add them using a plus operator. Step 4. Create list node from the resulting multi-digit number of the sum. Let's see the realized algorithm. As you can see, this algorithm works because this is the result of the method, which is 708, and output should be exactly like that. That's how it works. First we create a multi-digit number 1. We use the next method. This method goes inside the list node. It gathers digit by digit until the number ends. And then it reverses it because the number is reversed. Multi-digit number 1, which is 342, like it should be. Same goes for number 2. It uses the same method. It also reverses it. The result is the same. Then it adds them. It uses big integer because the cases in LeetCode, there are some that go outside of integer and long bounds, but big integer seems to be just enough for all the cases. Resulting sum, which needs to be inverted, is 807. And then the last step, we take the sum, we create a string out of it, we again reverse it, and then we create list node after list node until the number runs out. And again, the result is right. Now let's take this algorithm and put it into LeetCode and check how all cases work. Also, I needed to import big integer because otherwise it won't work. Seems like this import is not automatically included. All these cases are successful, but we need to submit it to check the speed. This solution is very basic. The biggest challenge is to correctly create numbers from list of digits and vice versa. It works and all test cases pass, but one could say that we avoided the core challenge of working with the list node structure, because we gathered its contents and cast it into a number, then did the simple addition of two numbers and converted it back. Given the description, it would make sense that we should not convert list node into anything else, but work with it directly. There is also another problem. While all test cases pass, the runtime is not ideal, and that makes sense. After going through the trouble of creating numbers, I then go through the resulting number to create list node. Avoiding the core problem costs us optimization, and also big integer has its limitations as well. So what would be a better solution? Let's go back to the problem. We have two multi-digit numbers presented in an unusual way. Even outside of the fact that these numbers are lists of digits, they are also reversed. Why is that? Turns out it is actually helpful for the correct solution. Now, we should remember how we were taught to add multi-digit numbers in school. We add each corresponding digit individually and put the result in the corresponding digit of the resulting number. If a sum of a corresponding digit ends up being more than 9, then the next sum of digits gets plus 1, and that's the biggest influence neighboring digits can have. There is also an interesting case if there are multiple 9s in a row, and that case is shown in the description, where plus 1 keeps influencing digits further and further. The simple way of adding multi-digit numbers from school is our correct solution. We only need to implement it working with list node. So the real solution is going through each digit, meaning each list node until nodes are finished. List node representing reverse numbers means they start conveniently for our addition algorithm. We also have to account for when digits of one number run out, but the other number still has them. Let's look at the program. Again, as we can see, the result is right. How it starts. We create contents for our resulting list node. This is where the result of each addition will go. We have a marker which tells that we are finished with our addition. That means that both of the numbers run out of digits. This shows the current generation digit for number 1. This is the same for number 2. Now we also need to keep remains from the previous addition in order to pass it to the next digit. This marker only changes once both numbers run out. So while it is true, we can go on through both of the numbers. Then it also changes the number from each cycle, and in case one of them runs out, it just makes it 0 because we have nothing to add to one of the numbers. It gets the sum of those digits, checks if we can go on. Then it needs to go to the next generation of digits. Remains should be determined because we need to add it to the next generation. And then the resulting list, which will then create a list node, receives another digit. After we run out of it, we also need to check if there are remains from the last addition, because we need to account for it. After that, we simply create list node after list node from our contents. After understanding the algorithm, let's see its results. As you can see, performance is much better, and also we are not limited by any number that could potentially exist, whereas in my original solution, there is a limit to big integer. If you have any questions, feel free to ask them in the comments. Like and subscribe for more LeetCode and all things Java.